Anytime? Anytime? Okay. Welcome to CSE 424. My name is Adam Lew, and I'm trying to solve the question of why are all these internet websites so successful in what they do? And through many hours of the dank power of the internet, I've come to the conclusion that it was recommender systems. So recommender systems are broken down into two major parts. We have content-based filtering and collaborative filtering, and put them together you get hybrid filtering. We're going to be talking about what they do, how they work, and the pros and cons each one has. These are my references. I use all these articles. The huge one was Dr. Brian Scassellati at the bottom from Harvard. He simplified and glued basically all my concepts together. It's really simple so that everyone understands. So this is the vague definition that everyone puts on the internet. We're just going to skip this because we're not English majors and put it all together. So my definition is it's a filtration system that presents anything that's likely to be of use to the user. All right. The main thing here is that it's likely to be of interest. We're not trying to get 100% correct here. We just need some sort of system to work. Now, if this still doesn't make sense here, we'll talk about this in sort of a black box, just how we do every other engineering system at ASU. A black box meaning, we don't really care what goes in, we just know something goes in and something comes out. You've actually seen a recommender system, well, not consciously seen it, but it's been working for you this whole time while you've been on the internet. You just haven't noticed it. It's kind of like a ninja. Now, if we give that ninja some information on decisions, ratings, or anything else you can possibly think of that has to do with the community, we end up with something special.
And his name is John C.
Alright, now that everyone's awake. GM, of course. Just think of it as a function, alright? It takes a lot of time and a lot of money. When I mean a lot of time and a lot of money, I mean a lot of time and a lot of money. Alright. That's the basic black box. Now let's think of this. What's inside that black box? What's the white box, alright? Let's talk about the first filter, content-based filter. What you want to do here is think of every single possible quality, what they had for breakfast in the morning, how fast it goes, any sort of product, anything, right? We're going to take that information. Oh, let's talk about chocolate first, sorry. Because chocolate is the most common thing on the market that you see every day. We're going to take that information, and we're going to put it into a table. Our goal here is basically to ask whether or not it's similar or it's not similar. But in reality, we can't just say, yes, Hershey's is similar to M&M's. We have to first say, no, it's kind of similar or it's not very similar at all. That's what we end up with in the end. It's sort of a numbering system. Now, what this allows us to do is, if we put in any keyword on, let's say, YouTube, Amazon, or anything like that has over 1 million different entries, now the query knows, okay, if he just entered dank memes, now we're going to put anything close to dank memes on his search query. And similarly, this means if you're trying to advertise a product to anyone, that also means that it would be a lot easier because we have factors we can just display on the webpage, especially those interns that don't know what they're doing on Amazon.com. All right, so let's see this in action. This is Akinator.com. Akinator.com works in complete reverse of what I just said. Instead of giving him a product and breaking it down into qualities, give him qualities, and then he'll break it down to a character. Now, if you don't botch his responses, he'll be basically 100% correct unless he has never heard the character before. And the boring part, when we see this in forward, let's say I look dank memes up on YouTube or Amazon, and then I look at a video or a product. If I click on that, what the content-based filtering is basically saying is, oh, you just clicked on a video or you clicked on a product. Let's just give him suggestions that are very similar. Now, there's a huge problem with this, though. I'm just looking for qualities, right? And remember this guy? Never gonna give you up, right? This guy? I'll tell you, man, if you haven't seen this guy, you probably have all your dreams assembled for you right now. This guy would break everything, and it's so simple. All you have to do is change the title, change the tags, change anything on a video. And what you end up with is the video that you didn't want in the first place. So the problem here is we can manipulate these qualities, and then you end up with Rick Astley just messing your entire movie feed up. Next is, let's say I share my account with a sibling, cousin, anything, right? Let's say I share with my sister. My sister is completely different from who I am. She'll look at videos that have to do with gymnastics or dance, whereas I'm going to look up dank memes, right? So we're going to have a skewed results, and we're just going to not have any sort of, the videos are just not going to match up. So to fix some of these problems, we came up with collaborative filtering. All right, collaborative filtering, let's just say I gave everyone in this room a thumbs up or a thumbs down. You just say, hey, let's give that guy a rating or not. And based off of what ratings you give on what different products, will sort of give you an archetype. So the movie Land Before Time, you can basically generalize every dinosaur and say every one of them likes a tree star, right? But in reality, we can't say that because let's face it, Kanye and Ramsey Gordon are going to fight about how good McDonald's is. One of them is just going to hate it, the other one's actually going to pull up the meat, right? So you can't archetype people based off of generalizations. You kind of have to create, again, a number system. So the pros here is that if we have a huge community like YouTube, Facebook, Pandora, Yelp, all these sites that have rating systems, you're going to have a really, really powerful website. The downside here is exactly what the pro is. If you don't have a community, it's not going to work at all, right? But to solve this, a lot of things, new features and new systems use better algorithms and have a lot of time to make their algorithms and systems. So when we have things like Pandora, who's been around for I think it's like 9 or 10 years, Netflix, same thing, you have a lot more time to create a better algorithm and also get rid of those skewed flyers that are messing with your numbers. Again, if you share an account though, that's not really going to help you. So this got so far where Netflix said in 2009, if you improve our system by 10%, we will give you $1 million. It's that simple. But if you put that in perspective of what they had to do, let's say it was a team of 10, it took them over 2,000 hours to complete this, over 107 algorithms. And if you put that in perspective, 1,920 hours per year is a full-time job. So 100,000 for a full-time job, not bad, but it was a competition, so you could have lost. Secondly, Netflix said, Dr. Scassellati said that if you have a recommender system, it will improve your revenue by 10 to 25%. But the main thing here that Netflix and Dr. Scassellati said was, no one really notices it in the first place, so no one really cares about the recommender system. What they care about is the interface. But again, these come hand in hand with each other. So if you don't have a good recommender system, you can't really guarantee a good interface because you won't have good results. So, how much time do I have? Okay, that's fine. So let's close it up, I guess. And basically what this means is recommender systems are going to be extremely helpful in the future based off of the fact that algorithms and time is going to continue to grow. But remember that it doesn't make or break your your application. Any questions? Yes.
I think it's potentially dangerous to have people have all of their content that they're getting, because most people use like Facebook as their news source.
Right.
So all of the news that they're seeing is selected to be news that they will like, i.e. news that agrees with them.
I kind of dislike that also, where there's, I think they were talking about where filters are getting to the point where you are losing most of your control now. So people are complaining about it. I completely agree that, yeah, if you put all your content up there, you're not going to get anything you want either. So definitely, it's a huge problem for these filters in the system now.
Well, not so much that you won't get what you like, so much you'll get too much of what you like.
Right. Okay. Yeah. And you won't see any variety of any other topics. Any other questions? Yes.
Okay, when you said that the content or the content filter and the filter system won't make or break the product because people won't notice them.
Yeah.
I think people won't notice if it's good, but if it sucks, they won't get it.
Right. Yeah.
So then, shouldn't it matter? Like, shouldn't they be putting a lot more money into it than like $1 million competition?
Right. No, it does take a lot of money. But I think the main point that Netflix was saying is if you have a good backbone, a good concept, and as long as you have a good sort of like business that you're trying to run, the recommendation system doesn't necessarily, I see what you mean by as far as like it needs to be good, but as long as you have like at least some relevance to the videos or the content that you put out there, like maybe 1 out of every 10 videos is relevant to what you just put up, at least you have something that's, of interest to the user. But yeah, no, you definitely want it to be good, but it doesn't need to be perfect. It's not your main priority. The application is always going to be your main priority.
The only thing I was going to ask you afterwards is, what is considered a good recommendation success? Like, what are 20 things that I put up there?
Yeah, I think what they put on Netflix was they were trying to hit 40%, and then they found that after they broke 40, it really didn't make a difference on the customer base. That was, I forgot to split the chart. Thank you. Any other questions? Yes.
There's a comment that I actually took a information retrieval class, which is how the science behind search engines.
Yeah.
And the filtering and recommending is actually part of the search engine, like Google and stuff.
Right.
And the math is like hell bending. I don't know what's happening. It's like an avatar there.
Yeah.
Any math?
I heard mainly from all the scholar, like the really, I'll just call it academic ones, the articles. They were all talking about matrix multiplication and addition. So if you can't do linear algebra, just Well, I'm gonna try it.
Any other questions?
I thought this was cool and a really huge part of computer science. I took I don't know if they have it here or what they call it, but there's a data mining class. I took it in college, and the final project was to take a stab at the Netflix prize.
Right.
What you were talking about there, and it was awesome. It was fantastic. So,
What was the results that they had?
It was just that. So it was just within the class,
Right.
the competition, and I think I ended up getting 70% accuracy on the subset. We didn't use the whole. I think it's like 3 gigabytes of network data.
Right.
We only used a subset, a very small subset, and yeah, it was hard. It was super hard. A good recommendation rate on it. But it was a cool challenge because you could throw all kinds of algorithms at it, and you're trying to get data out of it. And besides the recommendation system, the same technology goes into data mining and getting actionable business concepts out of whatever is available. So MasterCard, Visa, all these other companies, besides people that are recommending products to you, are trying to figure out how to do things like detect fraud and stuff like that. The same type of ideas, getting the information out of the big block of data, but applying to different things.
All right, thank you.